Good morning, everyone. A very warm welcome to all of you, and thank you for joining us today. It is truly pleasure to have leaders and professionals from across Indian mining ecosystem with us for this session. Over the next hour, we will discuss how location intelligence and geospatial technology support different stages of mining life cycle, from exploration and planning to operations, monitoring, and regulatory compliance. Thank you once again for taking time out from your busy schedule and be a part of this webinar. I'm Yogesh Karikarte, Group Manager and ISRI India. With me, we have Poonam Revre, who is imagery expert. Srikant is a mining and Python expert. We have Sarath, who is enterprise expert. And we have Samkit, who is imagery and drone data experts. Before we begin, a quick note to everybody. If you have any question during the session, please free to post them in the chat window. ISRI is a global leader in Geographic Information System and Location Intelligence. Founded in 1969 and headquartered in Redlands, California, ISRI provides advanced mapping and spatial analytics solutions. These solutions help organizations understand patterns, relationships, and trends through geography. This enables better and more informed decision making. To ensure continuous innovations in GIS and location intelligence, ISRI invests nearly 30% of its annual revenue in research and development. ISRI India brings this technology to organizations across the country. For more than 3 decades, ISRI India has been serving customers across various industries such as government, mining, infrastructure, utilities, agriculture, and retail, with solutions in geographical information system, location intelligence, and mapping. Today, ISRI India supports more than 6,500 organizations and over 1 million users. To serve customer better, we have a team of more than 700 professionals with offices in 7 cities across India, and our headquarters is in Delhi. GIS provides essential spatial intelligence required to manage the entire mining life cycle with precision and transparency. It centralizes critical data layers from topographical and geological modeling to real-time fleet management and infrastructure tracking, creating a single source of truth for decision makers. By integrating land ownership records and environmental impact maps, GIS ensures seamless regulatory compliance and proactive community management. During the active extraction, it monitors operational footprints to optimize resources recovery while minimizing the environmental disturbance. As the project moves towards closure, GIS-driven reclamation plans provides the technical foundation for successful land recovery and resettlement planning. Ultimately, these capabilities enable a more efficient, safe, and sustainable mining operations. Location is very important for mining industry, where the potential minerals are located, which area comes under the mining boundary, where are the assets or infrastructure placed, area where the environmental monitoring is carried out, all needs understanding of location. We also know that regulatory compliance are becoming more and more complex. The compliance report need to be submitted in timely manner. Mining companies today are required to regularly submit the digital information and spatial data to regulatory bodies such as Indian Bureau of Mines, the Ministry of Environment, Forestry, and Climate Change. Many of these submissions now happen through digital platforms. However, in many organizations, the information is often scattered across multiple systems. Geological data sits in one environment, survey data and mine plans exist somewhere else. Operational information and environmental reports are stored in separate systems. As a result, decision makers often have to rely on multiple reports, spreadsheets, and disconnected maps to understand what is happening on the ground. How do we bring all this information together to make better decisions faster with greater confidence? For this, we have a location intelligence platform, which brings all the data together. The platform can process satellite data and drone data sets. Also helps in spatial analysis, create reports and dashboards, and support decision making. This means accurate and reliable spatial data is becoming readily available, not only for the operations, but also for regulatory transparency and compliance. With that context, Today's session is designed to walk you through the practical journey of how spatial intelligence supports the entire mining life cycle. The first step in mining is to find out where the minerals are. Most of the time, these areas are remote and they are very difficult to explore. However, with the help of satellite data sets and through advanced spectral analysis techniques, subtle mineral signatures can be detected and interpreted to identify potential exploration targets. Specialized remote sensing tools like ENVI plays an important role in processing the multispectral and hyperspectral imagery and extract the geological insight from the satellite data. Mining activities also operate with dynamic environmental system. Events such as extreme rainfall or flooding can affect the mine pits, haul roads, infrastructure, and worker safety. Modern spatial analysis platform can simulate the events such as flooding by combining terrain models, hydrological analysis, and environmental data sets. To show how this works, I would now invite Poonam, who will walk us through the satellite-based mineral exploration and then show how a flood simulation scenario to understand the environmental risk. Over to you, Poonam.
Good morning, everyone. I'll be presenting a session on mineral exploration using satellite imagery and flood simulation in mining as well. Traditionally, mining companies relied heavily on field surveys and drilling campaigns. While these were accurate, these approaches are time consuming and expensive. So on the screen, you can see we have a very powerful image analysis platform called ENVI, which processes and interprets satellite imagery to identify different materials and patterns on the Earth's surface. Today, companies are increasingly turning into satellite-based mineral exploration to narrow down the potential areas before sending their field teams. So now, as you can see, I have so many options to select from for the optical sensors. So you can use any of the optical sensors and use any of the satellite imagery to process your according to your use case. So as you can see, now I will be using a freely available data set, hyperspectral data set, which is Hyperion's data set. So the big question for the companies become where exactly should we start digging? As we are now using an hyperspectral imagery, so unlike normal satellite imagery, hyperspectral imagery captures many subtle variations of the reflected light, which helps identify minerals better on the Earth's surface. The first step you see on the screen is preparing the imagery. Satellite images are affected by some atmospheric conditions such as haze, cloud, etc. So we correct these effects using built-in tools in ENVI to make sure that the data are accurately represented on the ground. So every mineral reflects sunlight differently. So right now, as you can see, I have used a method called QAC, which we call quick atmospheric correction, to correct my imagery. We do have something called as flash, which also does the same thing but with extra parameters. So with flash, we are able to remove all the atmospheric anomalies and can process the data beforehand. Every mineral reflect differently. As I said, iron bearing minerals differently, clay minerals differently. So by comparing the spectral information which we get from the ground with the libraries, we can get the exact minerals which are found in the area. So right now I have taken an AOI in Karnataka and I'm showing you the indices which are available with the ENVI. So these are the built-in ratios which you can use for your analysis. Right now I'm using iron oxide. On the left hand side, you can see I have taken 2 to 3 ratios to identify the minerals. So each of the ratios have their own classes. I have taken iron oxide index, ferrous silicate index, and clay alteration index. So based on these classes, we identify the dominant mineral across the area of interest and then analyze our area using spectral hourglass workflow. So what is spectral hourglass workflow? It is nothing but a clustering, it is a statistical tool to identify what kind of mineral is dominant over the area of interest. So by simply putting an input and a few parameters which are known to you, you can just identify which cluster is dominant. As you can see, the screen will be appearing with the classes which are dominant over the area. So as I move the classes, you can see class 1 is dominant over this area. Once I know that this class is dominant, I will compare it with the spectral profile, which is available within the ENVI software. You can see there are spectral libraries present over here. Based on that, I will move the cursor and see if what kind of minerals are present. After this, after this analysis, I get to know that this area is dominant with sandstone and red quartzite. As you can see, you can also calculate the area. Doing the same methodology, I will also identify that siderite and goethite are again present in this area, which is the part of red quartzite. Now next, we'll move from exploration to operations. Now let us shift this to operations. Flooding in the mining areas is not just a seasonal inconvenience, but it is an operational and safety risk. On the screen, you can see the ArcGIS Pro simulating the rainfall beforehand. So with spatial analysis, it becomes extremely easy to predict how the water will behave during an intense rainfall events. Now I'm trying to make an AOI, which is the area of interest, where I want to understand how the area or how water will accumulate over this area of interest. Once I am done with that, you will see in the right hand side, I have a dialog box appearing for configuring the simulation, where you can put in duration, rate of the precipitation, units per hour, this kind of information which will make you predict the analysis. Then you can also put in some water depth raster if available, then infiltration rate, maximum infiltration rate based on the soil type, and if you have surface roughness raster, you can use that as well. After applying this to the simulation will work for 1 hour and it will give you the resultant simulation. Once I click on the simulation here, you can see I have virtually created some rainfall here. You can see I will now turn on the rain as well for you to visualize it better. So after 5 minutes of the simulation, you can see how the basins have formed across the area of interest. So how does GIS create value here? This enables planning rather than the emergency response. It helps operators to redesign the layouts to minimize the damage. It also helps in identifying the high-risk zone and develop safety protocols. GIS makes it possible to demonstrate scientifically how runoff can be managed. This also ensures the business continuity, planning, and is backed by the spatial evidence. So as you can see, with a simple normal tool, we could identify that how the water will be behaving across the mining site. Now I will also zoom into the mining site and let you know how the water has accumulated over the area. As I rotate here, you can see how the water is behaving and how the water is accumulated over the mining site. Not only that, but also we get to know a lot of other parameters such as water depth, speed, flow rate, and directions. So with few inputs, tool was able to generate a flood risk zone within minutes, helping planners to have preventive measures. That is how the geospatial technology is helping in the mining industries with the flood simulation. With that, now I'll hand it over back to Yogesh.
Thank you, Poonam. What we just saw highlights an important shift happening in the mining industry. Exploration insights and environmental analysis are no longer isolated activities. They are increasingly part of the larger spatial framework that supports planning and decision-making across the entire mining life cycle. Once the potential mineral zone is identified, the next critical step is accurately spatial planning and monitoring the mining lease areas. Lease boundaries define where the mining operations are legally permitted. Any activity outside approved limits can lead to the compliance issues and regulatory actions. Mining organizations are therefore required to submit digitized lease boundary maps and mine plan to the regulatory systems. But beyond the regulatory compliance, spatial understanding is also important for the operational planning. Mining decisions require understanding what lies beneath the surface. Modern spatial technology make it possible to visualize the geological structure in 3D dimension, enabling planners and geologists to better understand the relationship between surface operations and subsurface resources. I would now invite Srikanth, who will walk us through the lease area mapping and 3D subsurface visualization. Over to you, Srikanth.
Yeah, thank you, Yogesh. Today, let us see how ArcGIS Pro helps us to visualize data that is collected from the boreholes. As you can see, we have boreholes. Boreholes typically contains XY coordinate system, depth, as well as lithology. Since this is tabular data, I have used some tools to convert this into spatial data. For now, I have used XY table to point to convert table to points. Once this is done, the points will be appear on the map. As you can see, my points appear somewhere near Bengaluru. Once I zoom to layer, these appear as 2D points. But to visualize it in 3D, we have to bring this data into 3D environment. To do that, I will bring this data into 3D scene. Once I bring this data into 3D scene, as you can see, boreholes are visible on the screen, but beneath the surface. To visualize this better, we will just turn off world imagery. Yeah. Now you can see all the parameters that are included like topsoil, limestone, sand, etc. has been symbolized according to their lithology. But we have only data that is representing boreholes, but we need to understand what lies between the boreholes. To do that, I am using something called empirical basin kriging. This is the interpolation method that helps us to understand what material lies between the boreholes. To do that, I am using a default settings and using linear type of method. And if you want to understand the tool, you can just click on help documents. We have a library of help documents for each tool available in ArcGIS Pro. As you can see, even we have Python code as well. Using Python code, you can also automate the process. Now let's come back to our ArcGIS Pro. Yeah. Once this is run, as you can see on the screen, empirical basin kriging layers have been added. As you can see, once I click on this, extend this, it will be having a same type of soil and associated with the numbers. But once we run this tool, as you can see, it changes according to the depth as well as materials is changing with the depth. Once this is representing a 2D layers individually, but to convert this into 3D, I'm converting it to NetCDF that is widely used across all my mining softwares as well. So to convert this, I'm using GA layer to 3D tool and I'm using parameters 1.5 X, Y and elevation. Once I run this tool, it will convert it into NetCDF format. Let me just turn on NetCDF layer. Yeah, as you can see, NetCDF format represents in 3D, but it is not representing individual layers. It is representing in range. As you can see, it represents from 2 to 6, but we need individual layers to calculate volume and assess mineral type. To do that, we have to convert this into voxels. Voxels are nothing but 3D cubes that represent material type. The concept is very similar to what we see in other softwares like block diagrams. So once this is done, let us see how each mineral type is behaving subsurface. Let me just go on to the symbology. Yeah. Once I go into symbology, if I want to see a sand, how sand is distributed between below the surface. Once I turn on the sand, as you can see, here you can see how sand is distributed. Similarly, if you want to see other type of material that is distributed, you can just turn on those layers. For suppose I am turning on highly weathered limestone. As you can see, this is how highly weathered limestone is distributed. And now let us see how we can bring in cross sections as well. To do that, I have created 3D cross sections already available. So as you can see, let me turn on the cross sections. Yeah, as you can see, this is how 3D cross section are represented. Now let's see how we can use slicing. Slicing is nothing but as we all use diagrams where we see material at particular cross section, it works in same manner. As you can see, once slicing is on, you can see at what interval what material is present. Once this is done, you can create this as a block as well. But if you want to calculate volume, how we can do is we have voxel counts that is represented. To do that, let me just drag the symbology layer. Yeah, as you can see, each voxel, I have already explained that voxels are nothing but 3D cubes that represent type of materials. We have voxels. To calculate volume, what we have to do is we have to multiply it with dimensions. I have given dimensions. You can see here, dimensions are given x, y, and z, 1.5, 1.5, and 1.5. You can multiply this with respect to count. You will get volume in meter cube. Now, let's see how ArcGIS Pro will help us in creation of layouts as well as reports. Moving on, as you can see, I have ArcGIS Pro open. I have created a map and shared it across my teams, field teams using enterprise capability. As you can see, This is the map that I have shared, and the people on the field has added all the layers that are required using mobile apps. As you can see, these are the parameters that they have digitized and added. As you can see, we have lease boundary pillars, as well as haul roads, as well as buffer they have created. Now let's see how we can bring in layouts. To do that, let me insert a layout. Here, when importing layout, we have some custom layouts that are available in beforehand. You can either use these layouts, or else you can bring in your own, where you can create according to your organization standards, where you can maintain consistency across the organization. So I have created a layout. Let me bring that in. Yeah, this is the default layout that I have created. As you can see, I have added things that are representing my organization. Now let's see how we can add in the map to layout. We can just go to properties and just import our mine site. Once it is done, as you can see, it falls directly on my layout, and we can set a scale or zoom to the layer that is representing outer extent. My outer extent layer is buffer, so I'm just zooming into that. Now, as you can see, legend is already populated here. And if you don't want to see any legend, you can just go to content pane and turn off those layers. This is how we can create a layout within a minute. Now let's see how we can share it. Now here is our sharing capability comes in. I'll share it as georeference PDF. Georeference PDF is a PDF that has spatial reference built in. So you can just bring that into any software. It will directly falls on the map. So let me export this. Yeah, once export is done, let's just open it in PDF viewer. Yeah, let me open this in PDF viewer. Yeah, on the right hand side, you can see there is something called layers in our PDF reader. Yeah, once we click on that, you can see the layers that have added in my ArcGIS Pro is visible here. You can just turn off the layers that are required for your decision makings. This is how ArcGIS Pro will help us to make decisions easily with the help of interactive PDFs. That's it from my end. Thank you. Yogesh, over to you.
Yeah, thank you, Srikant. What we have seen so far covers the exploration insights, environmental risk understanding, and spatial planning for mining operations. But mining companies today are evaluated not only on the basis of production, but also on environmental responsibility and sustainable commitments. The main important component for this hydrological modeling, plantation, and land restoration. When satellite imagery, field observations, and spatial data are connected, organization can create transparent system to map, monitor, and report plantation and environmental restoration activities. This is not only simplifies the compliance reporting, but the organization, but also it will help in the responsible and sustainable mining practices. To show how it can be done, I now invite Sarath.
Thanks, Yogesh. For this activity, we will be looking upon environmental, social, and governance related activities. And as a part of this one, we will be looking firstly and primarily on the water body impacting due to the mining activities. For this purpose, we have moved to the southern part of Pune near to Katraj, and we are seeing some of the mining activities related to the construction stone extractions. And we can see few of the mining activities are taking place nearby that one. And now let us first see, before going ahead, let us see how the particular mining site is having its digital elevation model. We can see here its height is ranging from 740 meters to 650 meters to its lowest digital elevation surface. And we can see some of the spots and areas that are inside the mine having a deeper excavations. And let us see in the overall perspective how a natural rainfall can be able to carry out some sediments from the mining area, which could impact the nearby water bodies. For this purpose, we have generated a stream network using GIS techniques, where we can see from the foothills of Katraj, it is navigating towards the mining site. And when we go near to that one, we can see none of the streams are originating into the mining area, but we can see one of the stream is originating from the mining site, which has a possibility of carrying sedimentation from it. And then we can also see there's one more channel that is joining from the right, which is also originating from the mining site. Possibly all these streams can carry forward with the sedimentation into the Katraj Lake, and further moved down into the nearby water body, which is present inside the Rajiv Gandhi Zoological Park. And we can see, when we see the condition of this Rajiv Gandhi Zoological Park, we can see a good amount of eutrophication is taking place because a consistent sediment flow is happening into this water body. And by this, it is actually impacting in the future, it will be impacting the water holding capacity of this water body and ultimately triggers into this flooding situation within the city. Not even that one, we can see one more mining site which is nearby, which is shown on the left hand of the initial mining site. This site is also contributing for the sedimentation flow from its stream during the natural rainy season. And when we go to the Jambulwadi Lake, we can see even eutrophication is started happening in the Jambulwadi Lake. If these can be able to be arrested, carrying of sedimentation into these water bodies could be conserved. So this is one of the environmental impact we can study before the mining or after the mining purposes. And this is one of the related for the environmental thing. Let us move to the governance and regulatory sides of it. Now we are looking at one of the mining area inside the forest area. And due to the mining activities, all the forest cover need to be removed. And as per the regulations and rules we have been knowing, whenever a deforestation takes place, double its amount of the size should be afforested. So let us now see what is the amount of deforestation took place due to this mining activity inside this forest area. When you look at this one being a default GIS system at nature, I think the area is around 0.51 square kilometers of area we can see. That is the amount of deforestation. Coming into these rules and regulations, nearly at least 1 square kilometer of area should be afforested at nature. But the main challenge for the mining companies is during the mining activity, finding of the areas for afforestation purposes. So let us see how ArcGIS, being an enterprise system, can able to solve this problem. So being an enterprise system, we have so many applications available, readily configurable at nature. And one of them we will be picking up for this is Survey 123. This is Survey 123 is a form where anyone can design with the requirement and the purposes of the activity. And in this one, as we have been investing heavily in technology like Yogesh specified, we will be using a Power Survey 123 design. So this is one of the latest technology enablement inside our suite of software, where we will be able to generate AI-based survey form. So this uses the large language model for generation of this survey form. So let us have a look how smartly it can be able to generate a survey form by having the enterprise system at your disposal. So let us just give a simple prompt here, like plantation request, survey form creation. So now, and let us go it for the requesting this one. It will be coming out with a little generation sequence of things that need to be captured. If we are not satisfied with it, we can again give the prompt for it. So let us see what it has given it for us. So it is giving about the contact information of the landlords who wants to lease out their land for the plantation or afforestation purpose. What is the location of it, and what is the site accessibility and site condition, and what are the related documents or supporting sites, photos or something. So when you are satisfied with it, you can ask for the generation. So it will be coming out with a survey form within a few seconds of time. So let us wait for it. It's almost done. Yep. And once the form has been generated out, let us see this one. We are getting all the information that has been given out during the generation of this one. And it is giving the location information, detailing related to who is requesting it, what is the type of plantation. But still, if you think some of the fields are missing, we can able to bring in standard fields or custom fields. For example, I was thinking that date is missing here. So I am bringing in the date or any other detailing we can be able to bring it up. And once we are done with it, we can able to publish it, which can be accessible by all the people who wants to lease out their land or who are interested in plantation support from the mining agency. And this gives a system of records, which can be further helpful in maintaining the system of records. So let us see which are the plots that has been leased out near to the mining area. So we can see here, when we look at the area that is being used for the afforestation or plantation purposes, it's nearly 0.13 square kilometers of area and nearby. It's not even that, these are the few of the plots across nearby mining area. We can also know one more factor. It's about the unit level dynamics. which is about the unit level inputs of each one, records about each and individual tree. So what is the tree that got planted, information related to that, and when it is being adopted, what is the height of it, what is the diameter in centimeters, and when it is being adopted on the date. So this gives a complete system of records where it further helps from end-to-end activities for system of records and generation of the reports accordingly. Okay, thank you, Yogesh. Over to you.
Thank you, Sarath. While satellite imagery provides a powerful regional perspective, mining operations also require frequent and high-resolution monitoring at site level. This is where drone-based data collection becomes extremely valuable. By integrating drone data with spatial analysis, organizations can maintain an up-to-date digital representation of mine site and support more accurate operational decision making. To show this capability, I would like to invite now Samkit. Over to you, Samkit.
Hello, good morning, everyone. I am Samkit Bagmar. I represent ISRI India for the imagery and the drone solutions business. So I'm here to talk about how you can use tools within ArcGIS, within the technology of ArcGIS Reality for surveying and mapping of your mine assets. So we have a technology called ArcGIS Reality, which falls within the ArcGIS ecosystem for field surveys or mine surveys that you regularly carry out. Within ArcGIS Reality, we have multiple technologies. We'll be talking about one technology today, that is SiteScan, where you can have a web-based application, which is a digital repository of all your mine sites present all across the world. So you can have this repository where you can ingest images from drones, process them together, create 2D, 3D models, do your basic survey functionalities within the technology itself. So all of this is deployed on a medium panel cloud so that you can have a single source of repository of all your mine sites within one single ecosystem. You can also give access to multiple team members from your team where they can log in and they can visualize their projects or their mine sites based on their roles and responsibilities. You can assign them different roles as well. So to begin with, I have chosen a couple of mine sites as an example. So this is one such mine site that you saw earlier, which my colleague had presented. Here we have captured about 357 drone images that we have brought in here. You can see the satellite imagery base map for your reference, and then these circles represent the individual geotag drone images. So these individual images are processed here together in an automated manner, and you can generate high resolution true orthos, something like this. So you can see this true ortho, which is captured, which is about 5 centimeters in resolution, which shows all the mine site, all the assets within the mine site. For example, let's say if you wish to measure a certain area or measure heights or mark certain points, you can do all of that using the tools that are available here. You can also generate elevation models such as DSMs. You can also generate terrain models and contours within this so that you can see how your elevation is changing throughout the surface. You can also create 3D point clouds. So this can help you, let's say, if you wish to measure certain heights or probably take elevation profile across some cross section, you can do this readily within this application. So here you can see how we have taken a cross section around a bench, across a bench, and you have plotted it over a map. You can extract this as CSV or LAS as per your desire. Along with this, you can also generate a high resolution 3D mesh, which gives you a virtual representation or a 3D representation of your site. So you can see all your mining assets that are there on the field in 3D. You can also visualize your haul roads, dump sites, dig out sites, and other periphery or other information that is available in your mine site in 3D. All of this is available on the web so that you can easily download it to your local system. You can share it across with others from your organization. Also, you can use it on ArcGIS Enterprise, publish it and use it on ArcGIS Enterprise, which we'll be seeing it in some time. Now here, I have another mine site, which was surveyed 3 times. So first it was surveyed on 27th of per month, and then 28th, and then 31st. So these 3 surveys, the periodic surveys that were carried out, had certain differences on ground. So let us see how they were different here. So for example, here we have the survey 1 information. You can see the pit information here. You can see the pit detail here. You have all the benches, all the mine sites. In fact, you can also see the dump sites here. Right? So all of this material that has been mined is dumped here. Now this is part of survey 1. So let's say if I wish to measure the volume of this, I have digitized this particular dump, right? And I can quickly see that this is about 1900 square meters in area, and the volume is about 140 meter cube, right? So let's say I wish to compare this survey, compare this site with my second day. So here I have my swiping tool with which I can see and visualize how the site has changed. Now I'm comparing survey 1 with survey 2. Right. So when I see the changes in day 1 and day 2, right, I can clearly see that some part of it is changed here. Now, when I visualize the same dump site that we had seen earlier, so where the material was there, about 190 meter cube, right? So if I see it in survey 2, all of that is cleaned up, right? So the material has been picked up and probably dispatched from the site. Now, let me compare survey 2 with survey 3. On the third day, when we see the same site, so a lot of material, new material has come in, right? So on survey 1, there was material, survey 2, it was all cleared out, and survey 3, again, there is new material that is coming. Now let me drill it deeper and understand how this change has happened. So I've just chosen this same polygon here that I had selected to compute the volume. I can visualize all of this in 3 dimension as well. So to visualize this in 3D, so I've chosen survey 1 and comparing with the base surface of survey 2, and I can see how the change is happening on ground. So when I compare survey 1 with survey 2, as we had seen earlier, the net fill volume was about 140 meter cube. Similarly, let's say I wish to compare survey 2 with survey 3. So I can choose survey 2 and compare it with survey 3 and get a net volume of about 904 meter cube, right, in the third day. So this is how you can clearly see and visualize the changes that have happened on site. You can also create accurate survey reports for your subsequent surveys, which will give you a detailed analysis, right? So for example, survey 1, I'm comparing survey 1 with the base surface of survey 2, which was an empty surface, and I can clearly see the differences that are there, right? So the survey 1 was about 140 meter cube, and survey 3 had about 905.77 meter cube of volume. So similarly, you can do this for all your dump sites. You can do this for your pits and every other surfaces that you have, and create these reports, download it or share it across with your organization or the relevant stakeholders within the organization and beyond it if necessary. Now let me take you to another mine site where we have this pit, and the benches and all this information with us. Here we also have some advanced cut and fill tools, right? So I have just chosen this cut and fill tool where I have chosen a level plane as a surface. So I can define a level plane. So let's say I define it as 145 meters, right? So all my points that are above 145 meters are very well captured here as compared to the points below 145 meters, right? So with this, I can clearly see how the cut and fill is changing over that particular site. Similarly, I can choose a file if I have a DXF or an AutoCAD file for the desired surface that I wish to have. I can choose that file and I can compare the cut and fill as well. I can also choose another mission, as we saw it in the previous example, right, where we had two different same site surveyed twice. You can choose that second mission and see how the changes occurred in a very simple manner. Of course, you can play around with the tools. You can change the opacity. You can change the cut and fill parameters and desired levels so that you can bring out your values much accurately as much as possible. You can also assign grids to it. For example, I've chosen a 15 meter by 15 meter grid. I can quickly capture these grids and I can see how the volume or how the grid-wise values are changing here. So for example, I have chosen a grid size of 15 meters. So the average elevation difference in each surface is about, since I had chosen a height of the plane of about 145 meters, the average elevation difference in individual grids is represented here. Similarly, you can also find the base elevation as well as the desired elevation that you had said. You can also compute the changes in volumes that are there in that particular grid. So this helps you in accurately monitoring your site in much more minute detail so that you can see how the site has changed over time. Now, going beyond this, so you have various other tools to monitor such as vegetation changes, length, area, height, volume, measurements, cross sections, and all of that. Beyond this, we also have a lot of AI capabilities where you can monitor your haul roads. So for example, I have digitized this haul road. I had taken a cross section and ran a haul road analytics tool on top of it, which gave me analytics for haul roads. So this haul road is automatically digitized using AI. Now let's say I wish to see where my haul road is falling in terms of width. So I can define certain parameters such as warning width, maximum width, and the minimum width that is supposed to be there. Right? Based on this compliant parameters that you input, you will get the hotspots where you need field inspection or where you need someone to visit the field and see if things are fine or if it is actually not within the tolerable limits. So you can quickly digitize this particular sites or these particular hotspots that you have noticed and share it with your field team so that they can go on field and look for those anomalies on ground. You can also run a couple of more checks like this. For example, berm height, right? So you can find out points or hotspots where berm height is a problem, where you do not have sufficient height in the berms of the haul roads. Road slope is again another one, as well as crossfall. So you can see all these failures wherever are a possibility that it could happen and take it to the field for field verification and next steps. Similarly, you can also use this to do other applications or using ArcGIS, I would say. You can download this data from here and use it on ArcGIS Pro for your advanced analytics. For example, I chose to download the point cloud from here for my advanced classification, and I can take it to ArcGIS Pro directly, and I can run my point cloud classification. So I have a lot of tool sets on ArcGIS Pro where I can classify my point cloud, where I can draw cross sections and capture the assets properly, where I have various ways such as automated classification, manual classification, as well as deep learning based classification of point cloud that can be utilized to extract ground features accurately. So all these tools are available within the same ecosystem of ArcGIS, where the data is easily transferable and usable. Now, I would also like to move to a few more examples where we can carry out drone surveys for all the plantation sites. So you saw how field applications could be helpful during the plantation studies that you carry out. Here, using drone surveys, you can accurately capture or precisely identify the locations where dugouts are where the plantation pits are dug out, and also monitor the health of plantation using multispectral data sets as well. Similarly, within the ArcGIS technology, ArcGIS reality technology, you can also consume satellite and aerial images as well to capture high resolution, to create high resolution 2D and 3D surfaces. For example, I have a mine site here processed with a satellite imagery, a high resolution satellite imagery of about 67 centimeters in resolution. So we just captured a couple of images, 4 to 5 images of this site, and we were able to create this high resolution 3D information. You must have noticed another thing, that this information, of course, this file is too heavy, and we are still able to open it as we have hosted this on a web application on the web, so that other users can also use this link and easily extract or capture information out of this. So this is how you can use ArcGIS reality within ArcGIS ecosystem or Israel ecosystem to capture your mine sites and do surveys on ground. Over to you. Thank you. Over to you, Vish.
Yes. Thank you, Samkit. Over the course of these sessions, we have walked through a journey that covers several stages of mining life cycle. From satellite-based exploration, environmental risk assessment, to lease management, subsurface visualization, environmental monitoring, and drone-based site analysis. What ties all these capabilities together is the ability to bring different data sets into a single geographical framework, enabling organizations to see the mine as a connected system and make more informed decisions. With that, we will now move into the question and answer segment.
Yeah, we have received a couple of questions. Although we have tried to answer a few of them over the Teams chat or over the this WebEx chat, there are a few more questions that we can take up now. Kartesh S has a question. Please explain how to import drone images and GCP align in the software. So there are multiple ways within the ArcGIS reality ecosystem that you can import drone images, right? So if you have geotagged images, you can directly import them. If you have images with a separate CSV file with the locations, you can import them separately as well. If you wish to bring in GCPs, you can bring in GCPs and use it for your geotagging, as well as you can bring in your checkpoints to monitor or have a check on the accuracies. You can search this on the web directly. You will find a couple of resources that will help you guide through this. If not, you can always reach out to info@esri.in and we will be happy to assist you with that. What is the spatial resolution and the source of these DSM and DTM? I'm not sure which spatial resolution and source of which of the demonstration that you're asking for. If it is a satellite imagery based, oh, okay, I think it is the drone DSM and DTM is what you're talking about. So the resolution of the data was about 5 centimeters when it was captured. So the DSM resolution is about 5 centimeters again. The DTM could be about 10 to 15 centimeters. The auto-generated DTM. If you wish to have a 5 centimeter level of DTM, you can obviously take it to ArcGIS Pro and classify it, classify the points and capture the accurate DTM there. How to calculate stock volume calculation in drone dataset? I think you had raised this question before I had covered that. You had a good demonstration on that, how you can calculate the stock volumes, right? So you just have to digitize it and click on the 3D visualization tab so that you can view it there. So there is another question. The survey 123 was taken in how many day interval? Okay, I think this question is answered.
No,
Can you help with the survey 123? So the question is, survey 123 was taken in how many day interval? Honestly, it is up to you.
I think Sankit, it's not survey 123. It's they are asking about the drone survey of
The
3
drone
3
survey
day
one.
interval. Right.
Day-wise
Okay,
surveys
got it.
which we have carried out.
Got it. Yeah. So the first survey was taken on 27th, second survey was taken on 28th, and third was taken on 31st. Right. So day 1, day 2, and day 4. Oh, sorry. Day 5 probably. 27, 28, and 31.
There is one more question. A mining project involves input from geology, environmental teams, and operations. How does ArcGIS help bring all this information together so that different teams can make better and more coordinated decisions? So as we were discussing, ArcGIS comes with the enterprise ecosystem where we can have different teams working on a single ecosystem. So the geology teams can bring their data, environmental teams, they can bring their data, and that the data can be put into the single system, and all who will have the access to the ecosystem, that enterprise, they can access the data and they can analyze the data also. So that's how all the data will be in a centralized system. Hope I answered your question.
There is another question. How to plot borehole data, borehole log data in ArcGIS Pro?
Srikant, would you like to answer? Basically,
Yeah.
Srikant had shown. Yeah, okay. Go ahead, Srikant.
Yeah, as I have shown, you can all borehole data will be having XY coordinates. So ArcGIS Pro has a capability to identify XY coordinates, and directly you can import that and plot it. I have used tool called XY2 points. That's the way you can do it. If you want to see it in 3D, you can just add Z factor to that, elevation factor that is, then you can just directly add that into 3D scene.
I guess we have answered all the questions that were in the chat box. We would like to wait for another 30 seconds if you have more questions that we can take up. Going forward, you can also write to us on info@isri.in. All right, so where we can address your queries after the presentation, after this webinar as well. I hope we have not missed out on any questions that were in the chat box.
So Ananya Saha is asking the log files at different depth, having different geological features. Sorry, Srikant?
Yeah. At different depth, we have we have to assign XY coordinates according to that depth. So when we do that, we'll have multiple points that is aligned vertically. So each point represents each material. That's how we can just import those points and represent them in 3D at different intervals. I hope that answers your question.
So basically what Srikant had shown was he bring in the XY, the Excel file which have the XY coordinates along with the Z, the depth of that particular mineral. And for each of the mineral, how much is the concentration, that is also available in that particular Excel file. And that Excel file he has bring into the ArcGIS Pro, and using the tools he had plotted in 3D. Thanks, Ananya. So I think we have all the questions covered now. We have a QR code also displayed on the monitor, which you can see for the scanning. You can scan and request for the demo through this.
Thank you, panelists. I guess we are done for this webinar today. I hope the discussion here and the functionalities we have showcased were insightful and meaningful to all of you. Thank you for your time to do. As next step, you will also receive the recordings for this webinar. And as you can see on the screen, you can reach out to us via our toll-free number, email, and website. If you wish to have any further discussions on the mining landscape. Thank you, everyone. Have a nice day ahead.